Alright, let's introduce our gas laws unit. And before we do that, we need to understand a few things. The first one being kinetic theory. And the things about kinetic theory is we must understand that particles of matter, all matter, are always in motion. It doesn't matter if it's a solid, a liquid, or a gas. All of those particles in each of those phases have some sort of motion. We also have to understand the volume of those individual particles is approximately zero, and that we get pressure from the collision of those particles with the walls of a container. That's what causes pressure. Particles exert no forces on each other, just on their containers, and the average kinetic energy is approximately equal to the Kelvin temperature of the gases. So whatever that Kelvin temperature of the gas is in general the average kinetic energy of those particles. And how do we measure pressure? Well, pressure first became measurable by a man named Torricelli during the 17th century, and he invented what's called the barometer. Now, many of us have heard the barometer before. The barometer is a device to measure that pressure of the atmosphere, and many of you see it or hear of it on the news every morning. They give you the barometer reading, how much pressure does the atmosphere have that day, and they can use that to predict the weather. But baro, the prefix baro means weight, meter to measure. So it's a way to measure the weight or the pressure that the atmosphere is exerting on us. Here's a picture of the early barometer. Notice the normal pressure due to atmosphere at sea level can support a column of mercury that's 760 millimeters of mercury high. Here's a couple pictures of some modern barometers. And notice that the higher the pressure, the drier it gets, the lower the pressure, the more chance of rain there is. So when we start to measure the barometer and we look at the barometer, it can tell us if there's a better chance for rain or there's a better chance for it to be a dry day. Sorry. So pressure units. Pressure units are something that we have to understand when we're talking about gas laws. And the pressure, again, is caused by the collision of the molecules colliding with the wall of the container. It's equal to force over the unit area. And the standard unit is the Newton over meter squared, which is 1 Pascal. One standard atmosphere is 101.31 kilopascals, and one standard atmosphere, which we say is ATM, that's what ATM stands for, is atmosphere. So 1 ATM is one standard atmosphere, which is 760 millimeters of mercury, that's what Hg is, or also 760 torr. Pressure units, the Pascal, and then there's the symbol for the Pascal, capital P, lowercase a. That is our standard pressure unit. There's the millimeters of mercury, mmHg. That's 1 millimeter column of mercury in the barometer. Then you have atmosphere, ATM, average atmospheric pressure at sea level and 0 degrees, and then the torr, which is 1 torr is also 1 millimeter of mercury. We're also going to be able to understand to convert Celsius to Kelvin. It's really very simple. You need to know that for every 1 degree Celsius you cool a gas, the volume decreases by 1/273rd. Okay. Negative 273 degrees Celsius is absolute zero, or 0 degrees Kelvin. That's the coldest temperature possible, and all motion ceases. We watched the video on this last Friday about absolute zero. So when we're converting Celsius to Kelvin, Kelvin is the degree Celsius plus 273. So obviously 0 degrees Celsius is 273 degrees Kelvin. If I went in the reverse, the degrees Celsius is equal to Kelvin minus 273. So 273 Kelvin, I subtract 273, that's 0, so I know it's 0 degrees Celsius. Standard temperature and pressure, which we call STP. The standard pressure is 1 atmosphere, which is 760 millimeters of mercury, or 101.3 kilopascals. And standard temperature is always 0 degrees Celsius, or 273 Kelvin. And finally, the nature of our gases. Gases always expand to fill their container. Okay, if we put a gas in a extremely large container, or we put it in an extremely small container, it's always going to expand to fill that container. Gases are fluid, which means we can pour them. They are able to move. They have a very low density. We can also compress them and put pressure on them, and they are able to effuse or diffuse. And we're going to stop there as our intro for gas laws.